y ya la última charla de esta mañana es a cargo de Gabriela Quiroga, del departamento de micro.
So, good morning everyone. My name is Gabriela Quiroga. I'm finishing my first year of PhD under the direction of Regulación, and today I'm going to present my thesis that is called Contribution of Maize Acuaporinas regulated by arbuscular mycorrhizal fungi to the transporting plant of water and other solids of physiological importance under drought. So first of all, what are acuaporinas? Acuaporinas are small membrane proteins, intrinsic proteins that are constituted by monomers that are inserted in the membranes as tetramers that where each subunit acts as a functional pore, transporting water and also other small and charged solids as can be urea, boron, silicon, CO2. They are present in different membranes, in the plasma membrane, but also in the tonoplast and the ER, and they are constitutively cycling between the organelles. Well, in plants, they constitute a large family, and maize, that is the plant that we are studying, they have at least 36 isoforms subdivided in 4 subfamilies depending on the sequence and the subcellular location. So as you probably know, arbuscular mycorrhizal fungi are present in most land soils, and they form a symbiosis with the roots of most plants, improving water and nutrient uptake by the plant. They were also demonstrated to enhance tolerance to abiotic stresses like drought, and when this symbiosis occurs, there were some morphological changes in root cells in order to accommodate the symbiont, and these changes could be modifying membrane proteins as acuaporinas. So in this context, 60 acuaporinas out of 33 were previously to this project found to be regulated by the mycorrhiza in maize. And this regulation was differently regulated under different drought stresses. So our hypothesis is that the arbuscular mycorrhizal fungi may be improving drought tolerance through the regulation of acuaporinas, and this would be influencing in water transport and also in the transport of other solids of physiological importance under drought. The final objective of the project would be the improvement of maize drought tolerance, as we know that maize is a fairly susceptible plant to this kind of stress. And I'm briefly going to tell you about the aims of the project. The first one is the identification of the key acuaporinas for drought tolerance that are related by arbuscular mycorrhizal fungi. For this, we analyzed 2 different maize genotypes with different tolerance to drought stress. We inoculated half of the plants with the arbuscular mycorrhizal fungi Rhizophagus irregularis, and we subjected the plants to drought stress. So, through the expression analysis of the 16 acuaporinas, we found 8 that were mainly regulated by the fungus in the sensible genotype, and that were differently affected by the drought stress. These 8 acuaporinas would be analyzed in the other objectives. So, secondly, we want to know if the effect of this regulation is improving water and solid transport. So for understanding this, we isolated single cells, protoplast, and we analyzed the water permeability of these cells for understanding if these inoculated plants are improving their water transport capacity. We also want to know if these aquaporins are involved in the transport in planta of solids of importance under drought. So as we know that these aquaporins could be transporting other solids as urea or boric acid, we want to know how they are performing under drought conditions with the inoculation. And finally, we also want to know if phytohormones like indolacetic acid or salicylic acid are involved in the inhibition of aquaporins during the symbiosis. We already have some results related to root conductivity, where we know that when the plant sits under drought, the regulation of root conductivity is different when the fungus is present with the hormone. So we want to know the relation with aquaporins as well. That's all. A nivel de acumulación proteica y transcripcional. O sea, vamos a mediante lisa las proteínas, pero también a nivel transcripcional.
Lo has dicho muy rápido y no sé si me entero bien. ¿Vais a utilizar siempre el mismo hongo intracálices?
Sí.
¿O vais a utilizar
No, siempre el mismo.
¿Y eso es porque sabes que es muy eficaz o piensas que todos los hongos van a tener el mismo efecto a ese nivel?
No sé si todos los hongos van a tener el mismo efecto. Lo que se sabe es que este hongo es eficaz para las plantas de maíz, para la sequía, y entonces utilizamos este. Probablemente la regulación sea distinta.
Pero no lo voy a utilizar porque es eficaz.
Sí.